Previous videos have shown you what you will do in modules M1E, M2, and M3 during session 1. This video will show you modules M4E and M5. They introduce one new idea, namely loops, and provide a chance for you to explore that and other ideas. First, I'll open module M4E. It is an example module, note the E in M4E, so there will not be any to-dos in it. Instead, I will run it and then read its code. Cool! Let's see how a simple turtle made that picture. All modules should begin with a green docstring like the one shown here. It should give a brief description of the module and list the authors of the module. Here, we see that this module will accomplish several goals. First, it will reinforce your understanding of using objects. Recall from a previous video that there are just three main concepts for using objects. First, you construct an instance of a class, where we call such instances objects. Second, you make an object do something by using what's called a method. Third, you reference an object's data by using what's called an instance variable. The second thing that this module will do is to introduce the concept of loops. More on that shortly. Third, this module will reinforce the concept of assignment, that is, how you make a name refer to a value, which will be an object. Names like these are often called variables because their value can vary, that is, change, as the program runs. Finally, this module will remind you how to use the dot trick to learn new things that you can do with simple turtles and more. Line 45 imports the Rose Graphics module, using RG as a shorthand for Rose Graphics. That just means that there is a module called Rose Graphics in your project or at some special place that the setup knows about. Importing it allows the program to access all the things defined inside that Rose Graphics module simply by typing the word RG followed by a dot, like this. As you can see, there are lots of classes, that is, types of things, in the Rose Graphics module, but we will only use the simple turtle and related classes in session 1. Line 46 constructs an RG turtle, giving it the name window. Line 49 constructs an RG simple turtle that uses the turtle shape and lets blue turtle be a name that refers to that simple turtle. Line 50 constructs an RG pen that will draw lines 3 pixels thick using midnight blue as its color. Line 50 also sets the blue turtle's pen to be that RG pen constructed on the right-hand side of that line. Note the notation for constructing, that is, creating and allocating storage for an object. Module name, dot, class name, parentheses, with whatever information, if any, that the object needs for its construction placed inside the parentheses, separated by commas. The class name identifies the type of thing being constructed. Turtle window, simple turtle, and pen objects here. The module name identifies the module, that is, file, where the details of the class appear. Line 50 also shows how to reference an instance variable of an object, as does line 51. For example, line 50 sets the blue turtle's pen to the pen just constructed. Instance variables are sometimes called data attributes because they are attributes, that is, qualities, of the object that hold data. Each simple turtle has a pen instance variable, but different simple turtles may have different values for their pens. One might have a midnight blue pen, another a green pen, and so forth. Here we see that simple turtles have a speed instance variable in addition to their pen instance variable. Line 54 makes the name size have the value 300. The pink comment suggests that the name size will be used to control the sizes of the squares to be drawn. At line 57, we see the concept that this video introduces, a loop. It makes its body repeat 13 times, where its body are the indented lines that follow the for statement. The body ends when the indentation ends at line 74. So, lines 60 through 67 will run once, then again, and so forth for a total of 13 times. There are many other ways to write loops, but for now we'll stick to this simple form: for, some variable name, in, range, parenthesis, some number, some integer, close parenthesis, colon, followed by some indented statements. You can use any non-negative integer in the range expression. The index variable, k in this example, is set to 0, then 1, then 2, and so forth as the iterations of the loop run. In this example, the index k is not used. Line 74 is not indented, so it runs only once after the 13 times that lines 60 through 67 run. Let's step back and think like a computer as we trace the run of this program by hand. First, at line 45, the Rose Graphics module is imported. That is, its code is read and made available to this program. Then, an RG Turtle window is constructed. That makes a window pop up. Next, at line 49, an RG Simple Turtle is constructed and hence appears on the screen. Lines 50 and 51 set characteristics of the Simple Turtle. Then line 54 sets the name size to the value 300. When line 57 runs, the name k is given the value 0. Then line 60 runs. It draws the draw square method of the Simple Turtle named Blue Turtle, which, judging from its name and watching the result of the program's run, draws a square that is 300 by 300. The Simple Turtle leaves behind a trail of midnight blue ink since its pen starts out being down, touching the screen. Line 64 runs next. It causes the Blue Turtle to lift up its pen so that subsequent movements will not leave a trail. Line 65 makes the Blue Turtle turn right, that is clockwise, 45 degrees. Line 66 makes the Blue Turtle move forward 10 pixels. Line 67 makes the Blue Turtle turn left 45 degrees. So now the Blue Turtle is pointing the same direction as it was before it drew a square, but is starting from a point that is a little below and to the right of where it started drawing the first square. Line 71 runs next. It tells the Blue Turtle to put its pen down so that subsequent movement will again leave a trail. Finally, at line 72, there is a key statement. Size gets the value size minus 12. Notice how I read an equal sign, an assignment operator here, as gets the value. When this statement runs, the computer evaluates the right-hand side first. It remembers that the current value of the name size is 300. It subtracts 12 from that, thus getting 288, and sets the name size to now refer to 288 instead of 300. Keeping track of how the names, that is variables, vary during the run is key to thinking like a computer and tracing code by hand. Most people need to use paper and pencil or sticky notes to keep track of the values of the variables. For example, like this for size and k. Size started out 300 and then changed to 288. K started out 0 and is not yet changed. We have now completed the first iteration of the loop that will run 13 times. The computer returns to the indented statement immediately following the for statement. Here, that is line 60. As before, the Blue Turtle draws a square, but the visual effect is different this time because the state of the computer changed from this second square. For the first square, the name size had the value 300, but for the second square, the name size had the value 288. The values of all the names that a computer is keeping track of is called the state of the computer. As this example shows, changing the state inside a loop can have dramatic results. After drawing this second square, lines 64 through 67 run again. They cause the Blue Turtle to move a little below and to the right of where it was for the previous square. So the state of the computer has changed not only via the name size, but also via the current position of the Blue Turtle, which the Blue Turtle keeps track of itself. After putting the pen down at line 71, line 72 runs again. Pause the video and take a moment to figure out what the effect of line 72 is at this point of the run of the program. I hope that you decided that line 72 makes the name size become 12 less than it was. That is, it makes it 288, its current value, minus 12, which is 276. So the state of the computer has changed again. Size is now 276. Line 72 ends the block of indented code, so once again we return to the first indented statement in the block, here line 60. K is incremented, becoming 2 at this point, although that is irrelevant to this example. Line 60 runs a third time, drawing the third square. Then, as before, lines 64 to 72 run, again changing the state of the computer. After they run, size is 264, and the blue turtle is still further below and to the left of where the previous squares were drawn. Lines 60 through 72 run a fourth time, drawing a fourth square, then a fifth time to draw a fifth square, then a 6th, 7th, 8th, 9th, 10th, 11th, 12th, and 13th square. After 13 times through the loop is done, and we resume at the first unindented line below the for statement, that is, at line 74. It causes the window to stick around until the user clicks the mouse, at which point the program completes its run. In summary, a for statement of the form for k in range blah makes the indented block of statements below the for statement run blah times. K is 0 the first time through the loop, 1 the next time, 2 the time after that, and so forth. The state of the computer during a run is the collection of current values for the names, that is, variables, that the computer is keeping track of. Assignment statements are one way that the state of the computer can vary from one iteration of a loop to the next iteration, so that each iteration can have effects different from the previous iterations of the same loop. During session 1 itself, once you have run M4E and reviewed its code, you will open M5. There is no E after the 5, so you should expect that there will be one or more to-dos in M5. Yes, there they are. Its to-dos tell you to put your name in the module, as you will always do, and then to type anything you want in the file, as long as you end up with at least 2 RG Simple Turtle objects. Each Simple Turtle draws something by moving and leaving a trail. Each Simple Turtle moves inside a loop. You can either type from scratch or copy and paste from the M4E module to give you code with which to start. Your choice. Here, I demonstrate the latter. I go back to M4E, copy the code, then back to M5, and paste it in. Now, I need to change it in some way, otherwise it would be no fun. Here's something that you might try. Change the left turn from 45 degrees to 45 plus k degrees. Recall that the for statement makes k start out as 0, then become 1, 2, 3, etc., as it does the 13 iterations. Since k changes each time through the loop, the state of the computer is different each time. In particular, the number of degrees to turn left increases by 1 each time through the loop, resulting in further changes to the state of the computer via the blue turtle's position. I won't run the program with this change, but you might try it when you do M5. It has a nifty effect, so you might want to remember that. Try changing the left turn from 45 degrees to 45 plus k degrees when you see this code in session 1. This video has shown you how you will do modules M4E and M5 of session 1. There will be lots of people to help you with the modules during session 1. So don't worry if you are fuzzy on anything at this point. Just have fun with the turtles.